Good evening, students. So today's video we are going to start with a question often asked by students while studying hypothyroidism, right? And that question is how hypothyroidism leads to yellow discoloration of the skin, right? Whenever we think of hypothyroidism or hypothyroidism, we often think about its effect on the basal metabolic rate, right? When we think of hypothyroidism, we think about lowering down of systolic blood pressure, rising up of diastolic blood pressure, narrowing down of pulse pressure, cold intolerance, brittle hairs, insomnia, weight increase, so many things we think about, and everything is somehow related to the basal metabolic rate, right? So whenever students come across this thing, that yellowish discoloration of skin, right? So they feel quite curious that how exactly the hypothyroidism can lead to yellowish discoloration of skin. So we will try to understand in this video how exactly the hypothyroidism can lead to yellowish discoloration of the skin. So let's start in a step-by-step manner, right? First of all, we'll draw a human being, right? Let's first of all draw a human being who is eating something, right? Let's draw his nose and mouth, right? So what this human being is eating, right? He is eating products like spinach, carrots, mango, sweet potato, right? Now all these things are rich in one substance which we call beta carotene, right? Beta carotene. Right? So many things which we eat daily are quite rich in beta carotene, right? Now what happens that he has eaten it, this food will go into his pharynx, esophagus, right? It will ultimately reach his stomach, right? Pylorus, duodenum. And when this food reaches the proximal part of small intestine, right? Here one enzyme is actually waiting for all this beta carotene which has gone inside, right? All the beta carotene which has gone inside, one enzyme is waiting to metabolize it, right? Okay, and what's the name of that enzyme? Right, suppose beta carotene has reached here, right? So one enzyme is waiting over here to metabolize it. We are enlarging the whole thing. So name of that enzyme is beta carotene 15 dioxygenase. Right? So this will break beta carotene into two compounds of retinol, right? Into two compounds of retinol. And retinol will be further reduced after several steps to retinol, right? You must have heard of retinol, right? In vision, right? It helps us in vision. It helps us many other things which we will discuss. Retinol. This retinol will get absorbed after binding with retinol binding protein, right? This will bind with, I'll write in short form, RBP, right? And it will get transported in blood, right? And what are the things retinol will help us in? It will help us in vision, right? It will help us in epithelial surface maintenance. It maintains the epithelia, right? Epithelial surface maintenance. And what else? It is going to help us in immunity also, right? So up till now, this human being has eaten all these foods rich in beta carotene. This beta carotene traveling all the way to GIT, reach our proximal intestine, and here the beta carotene was broken down with the help of enzyme beta carotene 15-dioxygenase into retinol, which was further reduced to retinol. This retinol was absorbed and carried in blood circulation with the help of retinol binding protein, which helps us in vision, epithelial surface maintenance and immunity, right? Up till now everything is okay, but this pathway is followed by just 90% of the beta carotene. That means most of the beta carotene is degraded via this pathway, right? What happens to the other 10%, right? Other 10% won't get degraded, right? The other 10% will go as beta carotene itself into blood supply, right? It will go as beta carotene itself into blood supply, right? Here this beta carotene is going to bind with lipoproteins present in the blood. It's going to bind with lipoproteins. And this lipoproteins will take it where? Any guesses? It will take it to liver, right? So let's draw a liver over here, right? Right? So beta carotene plus lipoproteins, it will take it to liver, and from there it will be excreted out. So perfect story, right? This man has ate all the carotene, and 90% of beta carotene is degraded by enzymes. 10% goes as pure beta carotene in blood, but it is conjugated with lipoproteins and sent to liver, from where it is excreted out. As simple as that, right? Now coming back to the question, how hypothyroidism leads to yellow discoloration of the skin. For that we need to understand what exactly our thyroxine hormone does, right? Now your thyroxine hormone is going to stimulate few steps over here, right? The thyroxine hormone is going to stimulate this enzyme, will improve the function of this enzyme, right? And also thyroxine hormone is going to increase the catabolic rate of retinol, right? It is going to degrade and increase the catabolic rate of retinol, okay? So if it stimulates this enzyme, of course this reaction will fasten up, and if the end product is being continuously degraded, right, in 11th 12th chemistry, right, if the end product is continuously being degraded, right, then this reaction will fasten up. So it is doing both the things to fasten up this reaction, stimulating this enzyme and also continuously degrading the end product. So as a feedback, the whole reaction will fasten up, right? What other thing the thyroxine is doing over here? The thyroxine will stimulate, it is going to stimulate the uptake of beta carotene plus lipoprotein, right? It is going to stimulate the uptake. So this will also be positively supported by thyroxine. Beta carotenes plus lipoproteins will get absorbed by liver and then excreted out, right? So thyroxine is doing three critical things over here, right? Now let's see. Now let's suppose hypothyroidism happens, right? Now if hypothyroidism has happened, then this thyroxine won't be able to stimulate. Now there is not enough thyroxine to stimulate this enzyme. Now there is not enough thyroxine to stimulate the degradation of retinol, right? So this whole enzymatic chain, this whole chain will slow down, right? And if this whole chain will slow down, it will no longer be able to process 90% of beta carotene, right? So the extra because of this chain has slowed down. So you will have now lot more beta carotene passing, right, as pure beta carotene into blood, right? Because this chain has slowed down, so you will have lot more beta carotene passing as pure beta carotene into the blood, right? Now, thyroxine was stimulating the uptake also, right? Thyroxine was fastening this chain, but it was stimulating the uptake also. Now there is not enough thyroxine to increase the uptake of this. There is not enough thyroxine to increase the uptake. So you will have lot more accumulation of beta carotene in the blood, right? And what else thyroxine will do? Thyroxine will increase the quantity of lipoproteins and also cholesterol. It will increase the quantity of lipoproteins and cholesterol. Right? So what will happen if the quantity of lipoproteins and cholesterol increases? Right? Now the circulating time of beta carotenes will increase. Now beta carotene can stay in circulation for longer time. First thing is uptake is not happening because there is not enough thyroxine to stimulate the uptake. Second thing is the carriers have increased, lipoproteins has increased, cholesterol has increased. So now it can stay in blood circulation for longer time, right? And this beta carotene is actually lipophilic. Now since it is lingering in blood for a longer time, now there is higher chance of its deposition in lipid rich tissues, right? One lipid rich tissue is the stratum corneum of the skin, right? So it goes and gets deposit in the lipid rich stratum corneum. Right? It goes and gets deposited in the lipid rich stratum corneum. Now, at which two portions of skin your stratum corneum is thickest? Your palm and soles, right? So it gets majorly deposited in the palms and soles. So where it is thickest, palms and soles, right? So it gets majorly deposited in palms and soles. Thickest stratum corneum is in palms and soles. Now one question often asked by students is that how we are going to differentiate this yellowish discoloration from jaundice, right? That's a very important clinical point, right? How we are going to differentiate this from jaundice, right? One very important differentiating point of carotenemia due to hypothyroidism and jaundice is that the sclera will be spared in carotenemia, right? This beta carotene won't get be deposited in the sclera, right? So sclera will be spared in carotenemia due to hypothyroidism, right? Other thing is the mild difference of color, right? This carotenemia is yellowish orange, right? And jaundice is lemon yellow. There is mild difference. This is yellowish orange, and in jaundice it will be lemon yellow. And of course you can get all the liver enzymes checked, SGOT, SGPT, ALT, right? Those will be elevated in jaundice and it will be perfectly normal in carotenemia, right? There can be very severe cases of hypothyroidism in which liver enzymes are elevated, but those are rare cases, right? In normal conditions, right, what you will get? The carotenemia, that is hypothyroidism induced carotenemia will spare your sclera, right, will be yellowish orange instead of lemon yellow color of the jaundice, right? And all your liver enzymes will be normal in hypothyroidism induced carotenemia and will be elevated in jaundice, right? So let's sum it up, right? A person has taken all the keratin rich foods. This keratin rich food has been degraded by your beta carotene 15,15 dioxygenase, which is broken down to retinol, right? Which is further reduced to retinol. Now thyroxine actually stimulates beta carotene 15,15 dioxygenase, and it also stimulates the degradation of retinol, right? And thyroxine also improves the uptake of beta carotene, pure beta carotene, which has gone inside the blood, right? So all the three steps are stimulated by thyroxine, right? In hypothyroidism, right, all these three steps will be impeded. This enzyme reaction will be slowed down. Lot more beta carotene will go into the blood, right? It will also increase the concentration of lipoproteins and cholesterol. Beta carotene, being lipophilic, is going to get deposited in the lipid rich stratum corneum, primarily in palms and soles, right? And you will get yellowish discoloration. So hopefully this video has helped you in understanding why yellowish discoloration can happen in hypothyroidism. Wish you all the very best. Thank you.